Okay, we have to, what is the most precise classification of a quadrilateral given these vertices? First graph these vertices. -3, -2. Let's label this A. -2, 2. We'll call that B. 1, -1. Call this C. 2, 3. Call this D. Initially, what do we want to call this? A what? A rhombus, or yes, correct. What did you say? A parallelogram. So it's either a rhombus or a parallelogram. It definitely does not look like a square or a rectangle or a kite. So let's talk about what it has to be if it is a rhombus. Sides have to be the same length. Diagonals have to bisect each other. And diagonals have to form a 90-degree angle. They have to be perpendicular. If this is a parallelogram, opposite sides have to be the same length. Opposite sides have to be parallel. So let's check this out. Let's see if we can classify the rhombus first. We must find the length of BD, which we're going to use the Pythagorean Theorem to find that length. Let's make a right triangle with BD being the third side. 1, 2, 3, 4. That side length of 4. That is a side length of 1. So BD has the length of 4 squared plus 1 squared, and then the square root of all of that. 4 squared is 16. 1 squared is 1. So BD is the length of square root of 17. Let's find the length of AC, the opposite side. Make a right triangle so I can use the Pythagorean Theorem. That is 4 squares by 1 square. So AC has a length of 4 squared plus 1 squared, which is the square root of 17. Let's find the length of AB. Make a right triangle so I can use the Pythagorean Theorem, which is also a 4 by 1. 4 squared plus 1 squared, square root of 17. And now let's check the last side, DC. Also a 4 by 1. So the square root, 4 squared plus 1 squared, square root of 17. What does this tell us about this figure?
All sides are equal.
Correct. All sides are equal. Okay, next, for this to be a rhombus, my diagonals must be perpendicular. I'm going to use a different color pen here to identify what we're finding. I need to find the length of, not the length, sorry, the slope of AD. So slope find the slope of AD, which is rise over run. So if I count right 4 spaces and up 4 spaces, my slope is 4 over 4, which is 1. Now I want to find the slope of BC. Okay, I'm going to start at B. I'm going to count down 1, 2, 3 spaces. So that's -3 on top. Okay, I'm going to count right 1, 2, 3 spaces. +3 on bottom because I went right. -3 over 3 is -1. These slopes are opposite reciprocals, which means AD, the diagonal AD, is perpendicular. This is the symbol for perpendicular, upside down capital T, is perpendicular to BC. These form a 90-degree angle. This is a rhombus. Turn the page. Alright, I like these ones. Okay, find the area of the figure. Let's break this up into pieces. Where do we want to start? I'm thinking we make this into one big square like that, or rectangle. Now, how should we cut this one?
Left.
Right here?
Yep.
Or right here? Right here?
Yep.
Okay. Okay. I'm going to redraw these chunks. I'm going to start with this one. This figure is 1 meter by 2 meters. This figure has a length of 2 meters. What is the height of it? It's 1 meter. Because if this entire side is 3 and the opposite side right here is only 2, that leaves 1 meter left over. And now I have my big rectangle. 5 meters by 3 meters. I'm going to find the area of all of these together, or separately, then add them all together. The area of this figure, 2 meters squared. The area of this one, length times width, 2 meters squared. 5 times 3, 15 meters squared. So over here, 15 plus 2 plus 2, I get 19 meters squared is my area. Okay, next, find the area of the trapezoid. Let's write down the formula. 1/2 times the height, base 1 plus base 2, times the sum of the bases. So let's count this height. The height is 1, 2, 3, 4. Let's count the length of base 1. 1, 2, 3, 4, 5, 6. Base 1 is 6. Don't just look at the number here and think it's 7. Didn't start at 0. 1, 2, 3, 4. Base 2 is 4. Plug all of it in. 1/2, 4 times the sum of the bases, 6 plus 4, which is 10. Plug all of this into your calculator. The area is 20 units squared. We could just put that. There is no given unit. Okay, so how did we do this? Explain how you found your answer. Well, I recognize It was a trapezoid. Then found the height, base 1 and base 2. I used the area formula for a trapezoid. This is just a squiggly. Started writing an R for some odd reason. Squiggle it out. Okay, a student calculated the area of this parallelogram as 3.6 meters squared. So write that. Explain your classmate's error. What is the correct area? Anybody think, how did they come up with 3.6?
2 times 1.8.
Okay, so 2 times 1.8 is 3.6. So they did the side length times the height. This is not the base. Remember, the base has to be 90 degrees off of the height. So this is our base. And this is the height. So the correct area is 1.8 times 2.5, which is 4.5 meters squared. Let's explain the error. The error not using the correct measure as the base. Okay, I'm told this is going to be a triangle. Here's the vertices. Graph and label the points. Determine if the triangle is equilateral, which means 3 sides are the same length. Isosceles, 2 sides are the same length. Or scalene, no sides are the same length. Include calculations and reasoning to support your answer. Let's go ahead and graph this out. There's x. There's y. Negative 2, 6. Here's z. Do we need any calculations to find zy? No, so let's start with that one. Zy has a length of 1, 2, 3, 4, 5, 6, 7. Let's calculate the length of yx. I'm going to make a right triangle so I can use the Pythagorean theorem. Length of 3, length of 4. So the length of yx is the square root of the two sides squared and added together. So 4 squared plus 3 squared. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. The square root of 25 is positive 5 and negative 5. But in this case, we're only taking the principal square root, which is 5, the positive number. Okay, so far none of the sides are the same length. I must check the last length. So zx, which is 4 squares by 4 squares. Do we think it's going to be the same as the others? No, we don't think so, but we still need to prove it. We don't think so because this is a 4 by 4, which is not the same as a 4 by 3. So the square root of 4 squared plus 4 squared, which is the square root of 16 plus 16, which is the square root of 32, which is roughly 5.6 if you plug it in. Let's simplify this for funsies, which is 4 times 8, 2, 2, 2, 4, 2, 2. So I circle my pairs. So this would be 4 square root 2, or approximately 5.61. So how can we classify this triangle? Correct. This triangle is scalene because, correct, all sides are not congruent. That's a bad way to write that. I think your version was better. None of the sides are the same length. Next page. Graph and label ABC the given vertices. Calculate the perimeter and the area of this triangle. -4, 7. A, -4, 5. B, 1, -7. C. What kind of triangle is this one? Somebody, I heard it. That's a right triangle. If we have a right triangle, what theorem are we allowed to use? The Pythagorean Theorem. So, let's count this length of BA. I counted 12. Let's count the length of AC. I counted 5. So my two legs are 12 and 5. I can use the Pythagorean theorem to find the length of the third side. So 12 squared plus 5 squared must equal the third side squared, c squared. $144 plus 25 must equal c squared. 169 must equal c squared. What is the inverse of squaring? Square root. So take the square root of both sides. So again, positive and negative 13, but we're dealing with distances and length, so we're only going to take the principal square root, which is the positive number. So the length of BC is 5. I just said 5, I don't know why. 13. How do I find the perimeter? Add up all these sides. That's 25. 25 plus 5. This triangle has a perimeter of 30. Now to find the area. Area is 1/2 times the height times the base. The base is 5. The height is 12. So I'm going to plug this in. 1/2 times 12 times 5. Area is 30, correct? Okay, next one. Okay, quadrilateral has given vertices. Determine the most precise name for this quadrilateral, supporting your answer with the appropriate calculations and reasoning. Also, find the area of ABCD. Let's graph it. A is 0, 0. B is 4, 0. C is 3, 2. D is negative 1, 2. Now, before we start, we do want to think about what we want to prove. What shape do we think this looks like? Yes, it looks like a parallelogram. So we need to prove what it takes to be a parallelogram. Our requirements are opposite sides must be the same length and opposite sides must be parallel. These are the requirements of a parallelogram. So let's find the length of DC. You counted 4? Again, you can just count it. Now I want to prove the length of the side opposite of DC. AB. AB is also a length of 4. These are my side lengths. Now slope. What is the slope of DC? I have a run of 4 but no rise. Slope is 0. The slope of AB run of 4, no rise. So that's 0. No slope for AB. So with this statement, we can say that DC is parallel to AB, and with this here, DC is congruent to AB. I must prove the same for my other two sides. The length of DA make my right triangle, which is 1 by 2. So the square root, 2 squared plus 1 squared, 4 plus 1, square root of 5. Okay, the slope of DA down to right 1. Negative 2 over 1. It's negative because I went down and right. Right is a positive, so negative over positive. Let's find the length of CB. If I make my right triangle, it's also a 2 by 1. 2 squared plus 1 squared, which is the square root of 5. The slope of CB, right 1 down 2, negative 2 over 1. What can we say about these two lines according to this? Yes, they are parallel. What can we say about these two according to this? They're congruent. So DA is congruent to CB. This shape I would call a parallelogram. Now I need to find the area of it. That formula is base times height. My base is 4. My height is 2. Four times 2, 8. Area is 8. Okay, last problem. Prove that the shape is a square by using the distance and slope formulas. Same process. Let's find the length of AB. Make my right triangle. This is a 3 by 3. So the square root, 3 squared plus 3 squared. 9 plus 9, yes, square root of 18. Let's find the length of BC. Also a 3 by 3. 3 squared plus 3 squared. Square root of 18. Let's find the length of CD. Also a 3 by 3. 3 squared plus 3 squared. Square root of 18. Let's find the length of AD. Also a 3 by 3. So 3 squared plus 3 squared. Square root of 18. Okay, to be a square, what else has to happen? What? 90-degree angles, which means my slopes must be opposite reciprocals. So we need to find the slope of AD, then the slope of DC. The slope of AD is down 3, right 3. -3/3. What is the slope of DC? Right 3, up 3. Are my slopes opposite reciprocals? Yes, so AD is perpendicular to DC, which means it's a 90-degree angle. Okay, let's prove that DC is perpendicular to BC. DC is 3/3. BC is right 3, down 3. So BC is perpendicular to DC. Let's prove that BC is perpendicular to AB. AB is 3/3. So AB is perpendicular to BC. I have 4 perpendicular slopes. It means I have 4 right angles. I also know that AB is congruent to BC, which is congruent to CD, and congruent to AD.